Hello, today we want to discussing the streaming and the source of this, particularly the source of the streaming. Anytime we develop a streaming applications, we need to test whether the streaming application works or not. For that to happen, we need a source of the streaming. In many cases, the streaming applications is streaming over the network. So that means we need to have a socket server streaming sources to provide the streaming data needed to test the functionality of the streaming applications. I wrote this application, the streaming source programs, in connections to testing the Apache streaming applications that I wrote. So let's go over this socket server Python programs that sends the streaming data over the network port. And this program is also available for download in my GitHub site. So at the end of this demonstrations, I will post the link for downloading. So this is a socket server program that generates non-stop random CSV lines intended as streaming testing sources with Apache Streaming. Its syntax is pretty simple. It's a name of Python 3, this sock_server.py space the port number. So you should choose a port that is a free and consider free port or greater than 20,000. So you may have a question is, do you have to specify the host name where this streaming the program runs? You don't. This streaming program listens to all interfaces at this particular port you specified. So since this is a Python program, there's some library I need to import. So import socket, import sys, import time, datetime, random, argparse. So you obviously know is it needs the parameter. So that's why I import argparse. So the parameter or argument it needs is the network port. This streaming server is listening on. So the first I create the method is called get_message. Basically, is really a 2 lines. The first line is creating a list. The list that contains 200 most popular English words. And the second one is random.choices k equal to 20 of this list, which means it will randomly pick one or any of these words in this list, and it joining back as a string that's separated by a space. And also very importantly, at the end of the string need to concatenate with a \n. Otherwise, the streaming client, particularly those Apache streaming, will not be able to receive the streaming data. That itself took me a little while to figure this out. So after that, it will be the driving programs. So the driving code is certainly, you will know it will asking for a port parameters, and it will make the port parameter is a mandatory. So you must supply the port parameter before it will go before it will follow over. So and then it will print out the port number just to confirm the port you have chosen, you have specified in as a parameter. And then you notice the host is empty. So the empty host means it's all interfaces, all network. If this machine has a multiple networking card, it will listen to all these cards in addition to localhost. And of course, the port you pass in will go to the variable support. And then it creates a socket. It displays socket created messages on the screen. And it binds the socket, so that's a typical procedure. So bind the socket with this host name, which is the empty, and the port number you pass in, and then bind the socket to the network port. And then it displays the socket bind complete. And then it will start listen to the socket. And it will display listen to the socket on this port. So now after this, it will wait for the client connections. So once there's a calling in from the client, it accepts, it gets the IP address of the client and the connection object. So, and then it goes into sending the messages. So what message? It calling the get underscore message, which returns a string that contains 20 random words. Some of these words may be duplicated, and certainly you will notice the dot encode is required when you send a string over to the TCP socket. It requires a byte string, not the regular text string. So that's why the dot encode method is needed. And after sending out the string, it will sleep for 1 second, and then sending another 20 random words encoded string over to the socket to the client. Once the client disconnects, it will break out this inner infinity loop and going back to waiting for a new connections, waiting for the new connections. So until when? Until you interrupt through the keyboard to end these programs. So you interrupt through end these programs, it will just close the socket and print done. So now this is the internal logic of this socket servers that sends out a random text string. So designed for, in this case, it's designed for Apache Spark word count program, network word count programs. So now let's go over to the network word count programs. We have shown streaming source programs, the sock server.py, which is a Python script. Since it is a script, it can be easily customized to whatever streaming data, such as the strings you want to send out via the TCP socket over the port. I have also written a simple client program that reads the port that the sock server.py sends out the streaming strings and display on the screens. And it is the client program used for sanity testing the streaming data the sock server.py sends out. There are two files. One file is a sock underscore client.cpp. The other one is sock underscore client.util.c. The client testing program is written obviously in C++ and C and used for sanity test. It will just print whatever the sock server sends out. So the following is how to build. First, you need to using GCC dash small f capital PIC dash C socks underscore client underscore util.c. So this is the source code, and dash O and the sock underscore client underscore util.o. So it compiles to the object file. And then run this g++ dash capital D have underscore long have underscore int underscore 64, and then you include the main files, the socket underscore client.cpp, and also include the object file you compiled previously, sock underscore client underscore util.o, and then link into a executable sock underscore client. So the syntax to run it is sock underscore client space the host name or IP address space the port number. So here is example how to run both. Example, first you start the sock server.py. So Python space sock underscore server.py space 29999. Assuming this is a Python 3 you already is a defaulting to. And it will the sock underscore server will display the port number, so it will listen to all interfaces over this port. So it will display first will display socket created, and then will display confirm socket bind complete, and then it listen to 29999 and waiting for client to call. Now you start the client programs. So / sock underscore client space, in this cases I just run on the same machine, so space localhost space 29999. It will display localhost, and it will display the IP address resolved from localhost, which is obviously 127.0.0.1, and then it will display the IP address to confirm this IP address, and also to confirm the port number you specify, and it will display anything that it received from the sock server over the port 29999 over the host name localhost. So once it attempt to connect to the localhost 29999, the SOC server will acknowledge connected with this particular whatever the machines that sends out, which is the IP address of the client machine, client program runs, and also the client port. And once on the client side, if you type Control C and then it stop it, the SOC server detected. It says client disconnect and waiting for the new client to calling in. Let's briefly go over these two client programs, the client files. One is the CPP files, one is the C files. So let's start with the CPP files, which is the main functions. So it obviously starts with the include all the header files and use namespace.std and then declare external functions, sock underscore client, which is included in the C file, another C files. That C file takes the two arguments. You will be imagining the first argument is a string that's supposed to be an IP address. The second one is the port, supposed to be the integer. And the main functions take the command line arguments, that needs the host name and the port. And then if you provide less than total number of the two additional command line arguments, it will exit and display the name of the client program, space the host name and the port, reminding you that you need to supply the host name or IP address and the port number. And if you do supply the host name or IP address and the port number, it will capture the port number and then assign to the long integer variable port. And then it will get the IP address. If you supplies, it will test if you supplies the host name, it will find the IP address of that host name and then send out back the pointer pointing to the host name structure. So inside the pointer variable is a host underscore entry. And then it will call the inet underscore ntoa and then gets the IP address from the structure into the IP address, which is a character string. And then it will call the sock underscore client as that pass the IP address and the port. Let's briefly go over the second C file, the files, which is a C files that belongs to the client programs called by the main functions. That C files contains a function is called sock underscore client. And that sock underscore client takes the two arguments. One is a server underscore IPP_ADR, which is a character string. The second one is the port, the server underscore port, which is an integer. And then it starts with include the header files and declare the necessary variables. And one of the variables is sock underscore addr underscore int, which is a structure. And it declares the server, which is the variable name, and the data type is sock underscore addr underscore int. So it starts with confirm the pass in the IP address and the port number, and then it creates a socket. So assign a return to the socket, the variables. And now it's assigned the IP addresses to the server dot sing underscore addr dot s underscore addr. So assign the IP address and assign the AFNet to the sing underscore family, which is IPv4, the family. And also assign the port to the server.sing underscore port. Then once assigned to the server variables and make the connections to the remote servers. So connect sock, which is the socket, and then the server, which is and also the size of the server, which is if it's less than 0, it fails. Otherwise, goes to the loop. The loop, it will read whatever the remote server sends out over the socket if it makes the connections, and the reply the whatever received is inside the server underscore reply. And then it assigns the heap memory, allocate the memory from the heap through the malloc, and then send a pointer to the reply. And then to be on the safe side, I just clean out the heap memory to make sure it's no junk inside. And then it will copy the server underscore reply it received whatever from the server, the remote server sends out into the heap memories pointed by the reply variables, and it prints out the content of the heap memory. And after this is done, it frees the heap memory and then sleep 1 second, and then go over again to read the next one until you Control C, and which it returns to the main functions. So here is the demonstration of the socket servers and the socket client. So I already started socket servers. You notice starting the Python space sock underscore server.py space 29999, which is the port. It will listen to all interfaces on these machines at the port 2999. So it will first display socket created, socket bind complete, and listen to 2999. And then let me make the connections. So I run the sock client. Sock client, I just type localhost 29999. So you notice it will display the client connect. It will display the client connect. And then on the client side, it will read whatever the text string. In this cases, you notice all the English word, the random word, separate by space and line by line. And then once you're done, you click the Control C, and then it exits out of the client program, and the server automatically detects the client has detected, they're disconnected, and they're waiting for the next connections. Now the streaming socket server is running. Let's connect the Spark Streaming application to the server. In these cases, the server IP address is 10.0.0.46, and port number is 29999, and give a test. And here is a simple Scala program's network word count that will read the text string over the stream host name and the port and calculate the word count. Just an example. So starting with importing the Spark library including log4j. So the first line of the main method is to set the log level at error. So therefore, it will suppress all the log that is less than error. So now define the Spark streaming configurations, and then define the streaming context, SSC. And then read the SSC over the stream host and the port. The host is 10.0.0.46 and the port is 29999, and gets the DS stream, which contains the RDD, into the lines. So since this line is receiving a single text string that contains a lot of words separated by space, then the flat map will separate these words into each individual elements and save into another RDD, which is the words. Then followed by the map. The map will map each word into a key value pair. The key is the word, value is 1, and send to another RDD, which is pair. And reduce by key will add up all the value 1 on the same word and save the results to the word counts. So the word counts is another final RDD. And then once gets the word count, it just print the word count out. Now let's start it with the streaming and wait for cancellations. So to run, I click the run configurations, specify the name, network word count, and also the main class, which has to be fully qualified reverse domain name, com.gentech.spark.network word count. So Gentech is my company. So let's click the run. So it obviously has received the text string over the streaming server and does the word count. So that's it for today. Thank you.